We'll proceed in parameterization in calculus. Why we need parameterization in calculus? That itself is a big question. Why we need parameterization? I have, I have, I have Cartesian coordinate. I am happy with it. What is the most basic? What is the most basic graph in 1D single dimension? Anyone would say it is the line. Line is the most basic graph in the algebraic graph in single dimension. What about 2D? Rectangle. Rectangle is the most basic graph in two dimensions. Why we need this is called Cartesian x-axis, y-axis, x-axis, y-axis. This is called Cartesian coordinate system, x-axis, y-axis. X-axis, y-axis. Now, if I have a rectangle here, that is the most basic thing in two dimensions. I have only x-axis, then a single line is the most basic thing in x-axis. What about x, y, z? I have x-axis, y-axis, and then z-axis. What is the most basic graph in 3D? Then there is a cube. Anyone would say there is a cube that is the most basic graph in the three dimensional. Okay. Now what about if I have now consider two dimensions x-axis, y-axis. This is x-axis, this is y-axis, two dimensions, where since it is perpendicular to each other, x-axis and y-axis, the the most basic thing what we imagine, the most basic thing what we imagine in the most basic thing what we imagine in a kind of Cartesian coordinate is a rectangle. But what about if I get a circle? What about if I get a circle? How a circle can be represented in Cartesian coordinate system? There we need different coordinate system. If I have if I have graph of something that is not rectangular, then we need different kind of coordinate system which are specialized in those kind of scenario. What is a circle? Consider the circle is centered at the origin. If circle is centered at the origin, then there is, if this is x-axis, then this is radius of the circle. And radius of the circle from theta angle, theta is growing and radius is rotating, making 2 pi angle and then making pi angle and then making 2 pi angle. So radius is rotating. This is typically called polar coordinate system where we have r and theta. Okay. Now, what about that in three dimensions? This is two dimensions. In three dimensional, I have a circle. I have a circle. That circle is placed on xy plane, and then there is a kind of cylindrical kind of system. There is z axis. There is a circle on xy plane, and there is a z axis. What about this? Then this will fall in cylindrical coordinate system. If I have a sphere, if I have a sphere, sphere means that on the xy plane, this is xy plane and I have a circle on the xy plane. Now, if I think about another circle, this is x, this is y, this is z. Now, if I think of another circle in x, z plane, another circle in YZ plane. If I combine all together, it becomes a sphere. So if I have a Cartesian coordinate system, then then manipulating the sphere is difficult. We need a specialization that would deal in the spherical. Then it comes as a spherical coordinate system. If it is cylinder, there is a cylinder, cone, they are similar, right? Then there is a specialized coordinate system come into the picture, is cylindrical coordinate system. If I have a circle, then a specialized coordinate system comes into the picture, that is polar coordinate system. Or if I have rectangular, then anyway it is Cartesian coordinate system. So in Cartesian coordinate system, if I have x-axis, y-axis, z-axis, and then if I bring a circle, then we think that someone would solve our problem in a better way. That is polar coordinate system. So do manipulation in polar coordinate system and then transform it back into xy Cartesian coordinate system. So if you see, if I see a circle in xy plane, then immediately I transfer the calculation in the polar coordinate system. When calculation is done, then I take it back into the Cartesian coordinate system because job is done. So it is something like that. There is a factory, cylindrical, cylindrical computation factory, polar computation factory, spherical computation factory, Cartesian coordinate factory. If I have to manipulate something in Cartesian coordinate system and it is cumbersome, it is difficult, then I pass this to polar coordinate system. Polar coordinate system, it does the work and then I transform it back from polar to Cartesian coordinate system. This Cartesian to polar, shifting it to polar, and from polar getting back to Cartesian, this is called parameterization. This is called parameterization. What is the area of a circle? What is the volume of a sphere? What is the volume of a sphere? Volume of a sphere, if I take Cartesian coordinate system, then I have xy plane. On top of xy plane, there is a sphere, x-axis, y-axis, z-axis. There is a sphere. What is the volume of the sphere? For simplicity, I am considering a sphere is centered at the origin with radius small a. Now, equation of a sphere is x square plus y square plus z square equal to a square. Z equal to square root of a square minus x square minus y square. If I try to calculate the volume in 3D, then if I have surface equation, then if I integrate it along xy plane, I get the volume. So surface equation is the square root of a square minus x square minus y square integration along xy plane dA, and then the limit of dA, then a square root of a square minus x square minus y square dx dy, and then we have to integrate it. X is minus a to a, y is minus a to a. Now go and integrate a square root of a square minus x square minus y square and then dx dy. It is very difficult. It is very difficult. Now can I can I do it in something that is very simple and get it back into the Cartesian coordinate system? So spherical coordinate system, the formula is again in a spherical coordinate system, the formula of calculating the volume is dV integration triple integration. Small volume if I take, small volume if I take, then triple integration. Or if I have Z value there also, F. Now what are the variable in spherical coordinate system? What are the variable in Cartesian coordinate system? X, Y, Z. What is the variable in spherical coordinate system? R, theta, phi, where R is the radius of the sphere, theta is the angle, on xy plane, if it is centered at xy plane, and then phi is the angle from the vertical. If this is the z axis, I mean vertical, then phi is the angle from vertical. Then if this is the sphere, then this full hitting the surface of the sphere is A. Phi is vertical angle phi, and this is A. A sine phi is the radius that falls on xy plane. A sine phi cos theta, where theta is rotation on the xy plane. So A sine phi cos theta is the x-axis, means more or less A sine phi sine theta. These are the conversion. But anyway, now what is the, if I take a small volume, if I take small volume dV, then what is dV? Vertical arc, horizontal arc, and radius. That is the dV. If it is dV, it has three components. So it is A. So vertical arc is A d phi, horizontal arc is A sine phi, A sine phi cos A sine phi d theta, A d phi, A sine phi d theta, and then dr. So it is now the dv is A sine phi. The dv at any point is A sine phi, and then A sine phi, and then A, I'm sorry, A d phi. Means if I have a sphere, okay, I really have a sphere. So if this is a sphere, and sphere, I want to calculate the volume of the sphere. If I am calculating the volume of a sphere, then this is centered at the origin. If it is centered at the origin, then I'll take any small portion inside the sphere, that is a small volume called dv. Then dv is vertical arc, horizontal arc, and dr. So it is from center, it is r distance. Then vertical arc is r d phi, horizontal is r sine phi d theta and dr. So r square sine phi, r square sine phi d phi d theta dr. That is the dv. Now integrate along. It is only spherical coordinate system. There is nothing called the Cartesian coordinate system. Now it terms as now r square sine phi d theta dr. Let's settle the r square. So r square dr is r to the power 3 by 3. Limit is 0 to a, that is the radius. So a to the power 3 by 3. Now sine phi d phi is minus cos phi. 0 to pi. Phi is 0 to pi. 0 to pi. Cos phi 0 to pi is 2. Okay, minus 2. So minus gone, 2. Now it came as 2a to the power 3 by 3 into theta, 2 pi. So 4. 4 pi a to the power 3 by 3 is the volume of a sphere whose radius is a. So nice, so easy, right? So easy it is. Now, if you calculate the volume through Cartesian coordinate, the square root of a square minus x square minus y square dx dy, and then limit minus a to a minus a to a, then someone would start seeing that star in the day only. But so easy. So if I have a shape, if I have a graph that matches a particular shape, spherical, cylindrical, polar, then it is better to do it in those coordinates and then transform it back. Okay, so that is the scenario. If I say what is the transformation, now I know that if something is there as far as a spherical is concerned, better to do in a spherical. But whatever, how I can get back in the Cartesian? That transformation from anyone to Cartesian or anyone to anyone, That is called parameterization. What is, if I know in Cartesian coordinate, if I know it is x, y, z, and there it is r, theta, phi in a spherical coordinate system, then what is the relationship? So that to and fro I can do. Why I can do to and fro, that we will see. Okay. Now what is the equivalent? Now x equal to any moment x equal to r sine phi. If I have a sphere centered at the origin, and there is this is the at the middle, this is xy plane, and if I take any a if it is in xy plane, a, if I can take a anywhere, if I take a or any r, okay, then if I take a, then from center it will touch the sphere, the kind of peripheral. a a sine phi would fall on xy plane. A sine phi cos theta is x. A sine phi sine theta is y. And a cos phi is z. This is the relationship between a spherical coordinate system and Cartesian coordinate system. What about polar to Cartesian? Where polar I have a circle with radius a and theta angle. It is in two variations, r cos theta, a cos theta I. A cos theta belongs to x and a sin theta belongs to y. Y equal to a sin theta, x equal to a cos theta. Spherical, if it is cylindrical, same thing, z equal to z. If it is spherical, x equal to a sin phi cos theta, y equal to a sin phi sin theta, and z equal to a cos phi. So this conversion from one coordinate system to any other coordinate system is called parameterization. I am trying to do parameterization of a spherical surface to Cartesian coordinate system. X equal to a is the radius of a sphere, a sin phi d phi, y I a sin phi cos theta, y equal to a sin phi sin theta, and z equal to a cos phi. Where it is used? No, no, no. I don't want to do in a spherical coordinate system. I want to do in Cartesian coordinate. So easy, right? If I have x-axis, y-axis, and there is a sphere kept at the center, then integration in Cartesian coordinate system is nothing but you have a sphere equation, integrate it along xy plane, you get the volume. Like if you're trying to calculate the volume, I'm trying to calculate volume of a cube whose sides are a, then the top surface of the volume, if I of the volume, get the equation of that surface and integrate along xy plane, you will get the volume. Simple, right? So what is the, if the full height of a sphere of a cube is a, then from xy plane a height is a by 2. Then equation of the surface is a by 2. Wherever you go in xy plane, it is a by 2. So a by 2 xy plane is dx dy. A by 2 dx dy. So dx, x is from minus a to a, minus a by 2 to a by 2, y is minus a by 2, a by 2. So dx dy will result into a into a. A to the power 3 by 2 is the volume of a cube above the xy plane. Multiply by 2, a to the power 3 is the volume of cube. So simple, right? So if I know the surface equation, quickly I can integrate over xy plane, and then I can get why I'll go to spherical coordinate system and this coordinate system. So the equation of the sphere is the square root of a square minus x square minus y square d of the xy plane, integration minus a to a minus a to a. Simple, right? But when I see this integration square root of a square minus x square minus y square, then my spectacle is becoming bigger. What I can do now? dxy plane, if I take in a polar coordinate system, then it will xy plane in polar coordinate system, the area in polar coordinate system, if I have a polar coordinate system and cylindrical coordinate system, now parameterization comes into the picture. Now, if I have d area here, d area there, then there d area is r d theta dr, r d theta dr. If that is the case, r d theta dr, then I can replace dx dy with r d theta dr. Here, the parameterization is coming into the picture. Now, x is r cos theta and y is r sin theta. So, x is r cos theta, y is r sin theta. It becomes square root of a square minus r square r dr d theta. Now, r square root of a square minus r square, the integration for it is square root of a square minus r square, because if I do differentiation, then it will result in minus r minus, okay, the integration, okay, so it will result, I'm trying r square root of a square minus r square. I believe it will be 1 by minus 1 by 3 minus 1 by 3 and a square minus r square to the power 3 by 2. If I do differentiation, then 3 by 2 would come out. 3 by 2 would come out, and then it will become a square root of a square minus r square minus 2r. So, 3 gone, 2 gone, minus gone r. So, it is minus 1 by 3 and a square minus r square to the power 3 by 2 is the net integration. 0 to a gone, and 0 to a, and if you put 0, then it becomes a square to the power 3. So it becomes a to the power 3 by 3, and theta is 2 pi. So then it becomes a to the power a to the power I mean 2 pi a to the power 3 by 3. Okay, since I started with Cartesian coordinate system, north hemisphere, I calculated, multiply by 2, 4 pi a to the power 3 is the volume through Cartesian coordinate system. In between, I use the polar coordinate system. But the fundamental I use is x equal to r cos theta and y equal to r sin theta, and dA is, we will see Jacobian later, and dA, that is dx dy, is r d theta dr. So this is where parameterization comes into the picture. When you are helpless in one particular coordinate system, then typically you try to use other coordinate system to solve the problem and then get back into the Cartesian coordinate system through the function which convert another coordinate system back to your original coordinate system is called parameterization. So I solved it through polar coordinate system. Now polar coordinate system mapping to Cartesian coordinate system is parameterization. X equal to r cos theta and y equal to r sin theta. Oh, can you tell me what would be the, if I say that I have a circle in xy plane, I have a circle in xy plane where circle is, where the polar coordinate system is r theta. What about our circle looks in r theta Cartesian coordinate? Means r theta is coordinate system, right? Where theta is one axis. Every coordinate system, the coordinates are orthogonal. If you take a spherical coordinate system, then there are three things: r, theta, and phi. If you take polar coordinate system, then you have r, theta. If you take cylindrical coordinate system, you have r, theta, and z. All three are perpendicular to each other. Mind it. If I take polar coordinate system, if I take polar coordinate system, then one side is r, one side is the arc that represent the theta, and other is radius. Radius and arc are perpendicular to each other. If you take cylindrical coordinate system, then radius and arc are anyway perpendicular to each other, then z axis is perpendicular to them. If you take a spherical coordinate system, phi represent the vertical arc, theta represent the horizontal arc. They are perpendicular to each other. And then radius if it is in xy plane, it is perpendicular to the horizontal arc. Otherwise, it is perpendicular to the vertical arc or are perpendicular to each other. So if I have a circle in Cartesian xy coordinate, how it looks in polar coordinate system, then there it is r, there you can consider as horizontal axis is theta and vertical axis is r, where theta is varying and r is varying. With that you will get a rectangle. Rectangle in polar coordinate system would map like a circle in Cartesian coordinate system. What about, consider that I have a coordinate system UV. Here polar, cylindrical, spherical. I have a spherical, I have a coordinate system called UV. One axis is U and other axis is V. Now there I have a triangle. There I have a triangle. Triangle is from origin 0, 0. One is 1, 0. Another is 1, 1. So 1, 1 is the one end of triangle. Another is 1, 0. And other is 0, 0. 0, 0. 1, 0, 0. 1, 1. And 1, 0. This is a triangle in UV plane. Now, can you transform into XY plane? Okay, tell me the relationship. Tell me the parameterization. Then it is x equal to v square minus u square and y equal to u into v. This is the parameterization. Can you tell me how this triangle in UV plane would look like in XY plane? Okay, now I have the horizontal line, vertical line and slant line. This is the triangle. Now if I take horizontal line, then v equal to 0. 0, 0 to 1, 0. V is vertical, V is 0. Then here x equal to v square minus u square. V is 0 minus u square. Y equal to 0. U into v. Y equal to 0. So in xy plane, if I say y equal to 0, then there is a line on the x-axis that spans from 0 to minus 1. 0, 0 to 1, 0 in UV. Then 1 in xy plane is v square minus u square. V is gone, minus u square means minus 1. So if this is the origin, this is minus x-axis, then one line will go from origin to minus 1, 0 in xy plane. Now if I go to UV plane again, I have a triangle like this, like one like this, one like this, and one is like this. 0, 0, 1, 0, 1, 1. What about this slant line from origin to 1, 1? Everywhere the u and v are same. 1, 1, half, half, quarter, quarter. If that is the case, then x equal to u square minus x equal to u square minus v square. X is gone. Both are same. And now y equal to u into v. So that will span from 0 to 1. So now in xy plane, I have one line that is origin to minus 1, another line origin to 1. This is in xy plane. What about the third one? That is the vertical in UV plane 1, 1 to 1, 0. 1, 1 to 1, 0. Now if you see 1, 1, then x is 0 and y is 1. X is 0 and y is 1. So in xy plane, that point is here. Anyway, I have two lines drawn on the x plane. One is minus 1, 0 to origin to 1. Now for 1, 1 and 1, 0 we are trying to map. So 1, 1 is here, 1, 0, 1. And what about 0, 0? So if I take 0, 0, 0, 0, then y is 0. Y is, if I take, another is 1, 0. So 1, 0 means y is u into v, y is gone. And x is minus u square, minus 1. So for next line, the one end in xy plane, is 0 comma 1 and other is minus 1 comma 0. Two lines already we have drawn. Now this is will result into x equal to v square minus u square. Now here in UV plane u is constant. If there is a straight line, u is constant. So u is 1 always. So v square minus 1. V will change from 1 to 0. Where y equal to u into v, then u is 1. Y equal to v. Y equal to v. Now x equal to v square. X equal to v square minus x equal to v square minus 1. Y equal to v. So x equal to y square minus 1. It's a typical formula of a parabola. So then in xy plane there is a 0 to minus 1 one line, x-axis, 0 to 1 along y-axis, and there is a parabola. So whatever inside the triangle points are, that will go inside the parabola. This is the mapping. This is the way someone can think. Then someone can map UV plane to XY plane. Why we go for different kind of coordinate system? Because our life would be easy. Typically in integration, life is very difficult. If it is differentiation, it's all right. What is integration of r by square root of a square minus r square? You tell me. Someone will start sweating, or someone will start seeing the moon in the day one. R by square root of a square minus r square. Chain rule and everything are difficult. So in that way, the method of substitution, in integration, primarily there are two ways to calculate the integration. One is integration by part and other is method of substitution. In method of substitution, we change x to something else, y to something else, z to something else, and we change dx, dy, dz accordingly. Actually, we are trying to divert a Cartesian coordinate into other coordinate system. If I talk about designing, this is typically called delegation. If you see the design pattern in software architecturing, this is called delegating. If you are not able to calculate integration in Cartesian coordinate system, you are delegating in substitution, in method of substitution in integration, you are delegating it to the other coordinate system. We will see. Like if I have a capacitor, then how you calculate the charge and current and those relationships in capacitor. So we will see it. So in that way, it is too long now. So in that way, we will use kind of method by substitution. Method of substitution in integration means you are taking it to different coordinate system to get it solved quickly and then that mapping from Cartesian coordinate to another coordinate system, that mapping is called that mapping is called parameterization. We will have more example. I believe you can take it as exercise that what about parameterization of a cone? Cone, cone in cylindrical coordinate system and Cartesian coordinate system. I have a cone. This is the base of the cone kept at the xy plane, and cone is like this. Cone is like this. This is the top of the cone. Cone is like this. If I have any point on the cone that is r theta z, r theta z as far as cylindrical coordinate system, r theta z. What is the relationship between r theta z and xyz? Okay, so if I take r theta z, if this is the cone, I take any point, the height of the cone is h. Consider the height of the cone is h. If I take any slant, if I take any point at that moment, consider height is z. Full height is h. At that moment, height is z. Full radius at the base is a. But at this moment, the radius, if I make a cross section, there is a radius, right? The radius is r. Now we have a, r, z and full h. Now if something rotates, then it is pi, theta. So theta rotates in 2 pi in every cross section, 2 pi. Whereas at the base cross section, The radius is a, that is the radius of the cone, base radius of the cone. At any cross section at height z, the radius is r, small r, full height is h. Can someone try the relationship between x, y, z and r theta z? R theta z. Then someone will say z is z. If I take any height, z is z, probably true. Then x is nothing but r cos theta. If this is the base where the radius is a, if this is the base where radius is a, if I go z height where full height is h, at any height z, if I make a cross section and this radius is r, then any moment it is at theta, then r cos theta is x, r sin theta is y, and height is z. X equal to r cos theta and y equal to r sin theta and z equal to z. True, but r is variable, right? The base radius is a and height is h. That is the only thing that is given. So, so now if I take any point r, any point here on the cone where the height is z and theta is theta and then r is r, how I can transform it into Cartesian coordinate? I can say r cos theta x equal to r cos theta, y equal to r sin theta, and z equal to z. But r can be transformed further. If this is the cone, and at any point we have height z, then if I take this as radius a and this is h, then a by h, because top angle is same. If this is the cone, then everywhere top angle is same. Means this is a, then a by h is same as if height is z. If I make a cross section, then r by this height. This height is nothing but h minus z. So r by h minus z equal to a by h. R equal to h minus z divided by h into a. Now the r cos theta, where the r r by z minus h. So where r is h minus z. So h minus z by h, a cos theta is x, h minus z by h sin theta is y, and z is z. Anyway, it is over, but you try from your angle, probably you will understand it more. Okay, so we will proceed on it. Then we will see Jacobian. So things are interesting. As I say, that numerical science, on top of it, algebraic science falls. But algebra is interesting, right? You have Cartesian, polar, and in numerous coordinate system. Mapping from one coordinate system to other coordinate system is parameterization. If I signify this in a vector form which is above the algebra, then it is parametric vector. So we will see more on it.